So in our last unit, we talked about some shortcuts for finding the derivative. We've used the power rule and the product rule and the quotient rule, but those rules and trig rules, but even those by themselves are not enough to encompass all of the functions that we encounter. And so the next shortcut, the next rule we're going to talk about is called the chain rule. And the chain rule is helpful whenever you have a composite function. And so we talked about composite functions last year. Whenever you have a function inside of a function, so f of g of x or f of g of x. And so remember when we did this, f of g of x meant that we put g of x in here, so 2x plus 3. And then we took this and put it inside function f, and so it became the square root of 2x plus 3. And so f of g of x was a function inside of another function. And the outer function here would be the square root, this one, and the inside function would be the 2x plus 3. And so when we're using the chain rule, we need to be able to identify which is the outer function and which is the inner function. So we're going to talk about how to separate those things out. But once we can determine which one is the outside and which one is the inside, then we can use this chain rule. And here's what it says. When we take the derivative of one of these composite functions, we're going to take the derivative of the outer function, this one, and the inner part will stay the same. And then we're going to multiply times the derivative of the inside function. So derivative of the outside, inside stays the same, times the derivative of the inside function. So this is kind of under the wrong pieces. This is that, and this should be underlined for that. Not sure why the underline and description is under the wrong thing. All right, so here's what we're talking about. When we look at this function, we should see the outer function, which is whatever is inside raised to the 5th power, and then we have the inside function, which is the 2x plus 1. So here's how the chain rule would work for that function. My derivative would be the derivative of the outside, so the derivative of this, which would be 5, and then inside stays the same. We have to finish that out, reduce by 1, so it's really just the power rule right here, times the derivative of the inside function, which is 2. So I just end up with 10 times 2x plus 1 to the 4th power. Okay, so that's our chain rule. The outside derivative, inside stays the same, times the derivative of the inside. So for some of these, we're going to need to rewrite them and then determine the outer and inner functions. So like on this one, we have that square root, which is the 1/2 power, and it's in the denominator. So we could rewrite this as y equals x squared plus 1 to the negative 1/2 power. And then I would have a power rule problem again, the outer function being the negative 1/2 power and the inside function being x squared plus 1. All right, so once I have the outer and inner determined, then I can use the rule. So the derivative of this power, so y prime is going to be negative 1/2, inside stays the same, reduced by 1, so negative 3/2, times the derivative of the inner function, 2x. All right, so 2 times negative 1/2, this 2 times negative 1/2 would just be negative 1 times x, or just negative x. And this x squared plus 1 is to the negative 3/2 power, so I could move that down here to the bottom to the positive 3/2 power. All right. So on this next one, remember that this really is the same as sine of x squared. When that little square is on the inside, it's the entire function squared. So again, this is a power rule. The outer function is a square. The inner function is sine x. And then we're going to take the derivative. The derivative of the outer, inside stays the same, times the derivative of sine, which is cosine. So I end up with y prime equals 2 sine x cosine x. And I don't know if you remember, but that one is one of our double angles. That's the double angle for sine. So that equals sine of 2x. All right, one more of these. So for this function, the inside is actually just the angle. The angle's not just a theta or an x, it's a 4x, which makes it its own function. And so the outer function here is the tangent, and the inside is the 4x. So when we take the derivative, we have the derivative of tangent, which is secant squared. Inside stays the same, times the derivative of the inner function, which is just 4. Or y prime is 4 secant squared of 4x. Okay, so on these two examples on the back page, we are going to be using multiple rules. On this one, we're going to be using the product rule because we have these two functions multiplied together, and this function is a composite, so it's got an outside and an inside. So let's talk about how to separate that. The outside of that would be the square root, or the 1/2 power, and the inside of that is going to be the 9 minus x squared. Okay, let me move that down just a little bit. So this is the outer, and this one is the inner. So when we get ready to take the derivative of this, we're going to be using both of those. So let's go through. Our product rule says that we're going to take the first function times the derivative of this second function, and that's where all of this is going to come into play. So derivative of this piece is going to be the outer derivative, 1/2, inside stays the same, reduced by 1, times the derivative of the inside, which is just going to be negative 2x. The 9 is just going to be 0. All right, so we have first derivative of the second plus the second, the square root of 9 minus x squared, times the derivative of the first, 2x. All right, so let's see if we can clean that up just a little bit. Once we have that done, we've done the derivative. We just need to fix it, clean it up. So this 2 right here times this 1/2 would just be negative 1. So I have a negative 1x right there. And a negative x times x squared would be negative x to the third times 9 minus x squared to the negative 1/2 power plus 2x times the square root of 9 minus x squared. All right, so this can go to the bottom. Now I have negative x cubed over 9 minus x squared to the 1/2 power plus 2x times the square root of 9 minus x squared. Now, we've talked a little bit about this. We don't necessarily need to leave this as two separate equations here, we need to write it as one fraction, and so I'm going to get a common denominator. So I'm going to put that over 1. So I need to multiply both sides by this denominator. So I'm going to multiply by 9 minus x squared to the 1/2 power over 9 minus x squared to the 1/2 power. Well, this is just the square root of 9 minus x squared. So here's what I'm going to get. I have negative x cubed, and then over here I've got plus, because I'm just combining all of this right now. So plus 2x, and then the square root of 9 minus x squared times the square root of 9 minus x squared is just going to be 9 minus x squared. All over 9 minus x squared to the 1/2 power. So now I've cleaned up all of this stuff on the numerator so I could distribute. And I'm going to have negative x cubed plus 2x times 9 would be 18x. 2x times negative x squared would be negative 2x cubed over 9 minus x squared to the 1/2 power. And our last piece of this, we've got our final answer here. We can combine these together. So we have negative 3x cubed plus 18x over 9 minus x squared to the 1/2 power. All right, so let's review for a minute. All of this first row is our new chain rule. Everything after that row is just algebra. So let's review. First times the derivative of the second, and all of this in the brackets is the derivative of the second because we have to use chain rule. Bring this down, the outer derivative, inside stays the same, times the derivative of the inside, and then plus the second times the derivative of the first. All right. One more example. This one, we're going to use quotient rule. Now, the quotient rule is also going to involve chain rule because down here in the bottom, we have a composite function. And for this one, the outer function, I'm going to put it over here. The outer function is going to be the cube, and the inside function is going to be the x squared plus 2. So when we get to this part, we're going to need to use these. So here we go. For our derivative, we have the bottom times the derivative of the top minus the top times the derivative of the bottom. And this is where I'm going to use this stuff. So the outer derivative is going to be 3, inside stays the same, reduced by 1, times the derivative of the inside, so times 2x. So bottom derivative of the top minus the top times the derivative of the bottom. All over the bottom squared. All right, so let's see what we can do with this. This is just going to be x squared plus 2 cubed. Over here, we could square this, but I think for right now, I'm just going to take these monomials, the 2x times the 3 times the x, and put those together. So 2x times 3 is 6x, times another x would be 6x squared, times x squared plus 2 squared, all over x squared plus 2, and a power to a power right here, we multiply, so we get 6. Now, since it is all one fraction, so we could kind of say that we're done. However, all of this will reduce, because if you'll look, every one of these terms right here, this term, and this term, all have x squared plus 2, x squared plus 2, x squared plus 2. So I can factor out from each of these two terms an x squared plus 2 to the lowest power, which would be the square. And when I do that, when I factor out x squared plus 2 squared from this, I still have an x squared plus 2 left over. And from the second term, when I take out x squared plus 2, the whole thing is gone, and I have minus 6x squared. Over our denominator. Now I can take these and reduce with these, and then combine like terms up here. So x squared minus 6x squared, we're going to get negative 5x squared plus 2 over x squared plus 2 to the fourth power. So on these problems, whenever you get to this point where we could have squared this and raised this to the third power and combined a whole bunch of stuff and made a really long polynomial, but that's not what you want to do if you can see that they all have something in common, because we could reduce this and make it a whole lot easier. So remember, you can always factor out the lower of the exponents, in this case the 2 or the second power. Just pull that out and then put what's left, and we can reduce. All right, so these problems for your homework, some are going to involve product rule, some are going to involve quotient rule, and some will just be a basic chain rule. But we're going to have a lot of practice, and we're going to also add in some trig functions. We'll work on that again. I guess that'll be Monday.